continue on with this theme. What are some sufficient conditions to prove it's a parallelogram? The next condition they asked us to consider, what about a quadrilateral that has two distinct pairs of consecutive sides that are congruent? If we have that, does it have to be a parallelogram? So, kind of breaking this apart, it's a four-sided figure. It has two distinct pairs of consecutive sides that are congruent. And that sounds an awful lot like a definition that we've been hovering around here quite a bit in the recent little part, and that would be a kite. And the fact that if we had a kite, that it would not have to be a parallelogram. And we looked at those earlier, and I don't think I have that one loaded, and maybe I'll just pause here, go load it, and I'll come back and show you that counterexample quick. Okay, here's the counterexample that I could show you very quickly, is that if you have two distinct adjacent sides, that it has to be a parallelogram. So we have two distinct adjacent sides that are congruent. Here's an 8.9, there's an 8.9, there's one pair, and here's another one, 5.27, 5.27, there's a second pair. That's what it means by two distinct adjacent sides that are congruent. And if that's the case, it does not have to be a parallelogram. Here's a whole bunch of them that are not. The only time that it would become a parallelogram is if I could move this in just the right position. And you can see the numbers on the left are getting smaller. The numbers on the right, I'm looking on the left, they were getting smaller, and the numbers on the right were getting bigger. Then I hit that break point. Now I'm going to come back this way. And you see how they never quite get equal, but if I got them to equal, you would see that it's a rhombus. And that's the one case where it would be. But the point of the matter is, it wouldn't have to be. If we are given that there are two distinct adjacent sides that are congruent, it does not have to be a parallelogram. The only time that it would be is if we were to put it exactly in the position of a rhombus, which is very touchy and hard to do on this. But so the case has been proven. Here's what we're saying. We got a counterexample to say that is not true. So you could again click on that hot link if you had GeoGebra downloaded on your computer. But our counterexample is simply kite. If we follow the directions, and it says that you have two distinct pairs of consecutive sides that are congruent. If that's one pair of consecutive sides, there's our other pair of consecutive sides. So if these are equal and those are equal, it does not have to be a parallelogram. It's a kite. So there are some things that we're disproving as well as proving. That is not a way to prove that it's a parallelogram.